So we now have a program that does a little something. In fact, it's a little program that could be its own function. And a lot of what we do when we write software is to write programs that do a little something and then build all those little somethings into something a bit bigger. There's actually a book about this that suggests that the human brain can be broken down into these little blocks, tiny agents that do little steps, and all of those little steps add up into something pretty substantial. So when you have something like this, it has a very specific goal, which is to sort of assess the length of names. It makes sense that it should be its own function. We have built-in functions that we've already run into. Things like print and len. There's several hundred other built-in functions, and then there's thousands more that you can add in as kinds of modules or toolkits. We'll be encountering a lot of those along the way. In fact, you might think of Python as being kind of, as I've said before, the glue that holds together a bunch of these various tools and lets you feed information from one to the other. So maybe we should make this little program we have into its own built-in function, or rather not built-in function, but its own defined function. Why don't we define it as a function so that we can reuse it and have our own function? Maybe we could call it assess name. So let's get rid of this part up here, and we'll go ahead and make this part down here that we've written into a function. We can get rid of this bit. So to define a function, we say def, that's to define, then the name of the function, let's call it, I don't know, assess the name. And then because it's a function, it needs to have those parentheses, but we're going to pass the name to it. So we'll put my name in here. So in this case, we're going to, when we call this function, when we try to use this function, we'll say assess the name, and then in here, we're going to put the name that we want it to assess. Now, everything that we want to be part of the function needs to be indented. Remember, indentation kind of tells you what's part of what in Python. So we can kind of put this in by a little bit, and that says this whole bit is going to be defined by the part there. So let's look at this real quick. This defines a new function that will then exist wherever we want to use it later on in the program. And anytime we call assess the name with my name, it will go up and do something with that. And in this case, what it will do is print some stuff to the screen. Let's just start with that. If we run it, it thinks for a while, and it ends up saying nothing, because we haven't actually asked it to do anything here. We've actually just defined a function. We haven't. All this other stuff is stuff that will be done when we use the function. But in this case, we haven't actually used anything. We've just said, here's a new function that we want to be part of Python that we can use in various ways. So then what do we do with that? Well, let's try actually using it. So we'll add in a bit here where we try assess the name, which is our function, and then we're going to pass it a string because that's kind of what it's expecting. We haven't said that explicitly, but I suspect that if we put something else in there, it'll break. So let's go ahead and pass it a name. We'll pass it Alex. Way too short because it's not my full name, I guess. So that seems to be working the way we want. We actually have a new function here that we can call anytime along the way. We would actually probably print that, right? Because although we can in this environment we can ask for a statement, we usually would print something as part of a program. So we would say print the assess the name, and that doesn't make sense because really what it's doing here is it's printing it in the function. And that's not the way functions usually work. They don't usually produce output directly to the screen or send things to files or anything like that. Usually what you do is you ask for the function. For example, if I do print len, remember len is the length of something. In this case, what it does is it returns a value. It makes this len Alex becomes the value of 4. So in some ways, we'd like for it, the report, rather than printing, we'd like it to become what that is, right? So for example, we don't want it to print it when it does that. We just want it to produce these strings. All right, we're going to do a few things to do that. We're going to have a string, let's call it response. So this is a new variable, right? and we're going to say that response is empty to start with, right? Now remember, this quote just means it's an empty string. There's a reason for that. I'll show you what it is in a second. First, I'm going to go down here, and I'm going to do, we haven't talked about this yet, so I'm going to talk about it for just a second here. A thing. It's a terrible name for a variable, but that's okay. We're there. So let's do a thing and have it equal to Bob. And then let's go ahead and print a thing. All right. So we know what we've done here. We've put Bob in here, and then we printed it, and we come up with Bob, right? Now, if we then say a thing, and we change it instead to tail, what's the output going to be? Well, it's going to be tail. And the reason is that when you assign this, when you put this in the box, and then you put something else in the box, the second thing you put in the box bounces out the first thing, right? It just jumps it out. Now, one thing we could do instead is we could say a thing equals a thing. Oops. We could do a thing equals a thing plus tail. Now in this case, what it does, instead of just bouncing it out, it takes what's in there now and adds it to tail and then assigns that into a thing. So let's take a look. So in this case, it just tags it onto the end there, right? So we can do that to add up numbers or whatever else we want to do. We take what's in the variable and we add something in. This is long enough that we don't usually do the repetition there. There's kind of a shortcut here, which is we can instead say, because we end up doing this a lot, we can say, instead of equals, we can say plus equals. And what that does is instead of bumping something out of what exists in the variable now, instead of just dropping that out, it instead goes ahead and adds whatever's in here to whatever's already in there. Does that make sense? So this kind of takes what's in there now and is the same as a thing plus equals a thing plus tail. So it just collapses it in. That little plus equals is kind of an append or add into what's already in the variable. All right, that's going to be important for what we're going to do up here in just a second. So we've started with an empty string, with a string that has nothing in it. And what we're going to say is if my name is more than 20, we're going to go ahead and not print anything anymore. I'm going to get rid of that. And we'll get rid of all these prints actually, because we don't want this to be printing things. Get rid of that. And we'll get rid of that. So we don't want it to be printing things. Instead, what we're going to do is we're going to add what is in that string that we have over there to what's in the response string already. So what this says is take whatever in the response string, which is going to be nothing to begin with, and add in what's right there after it. We'll go ahead and do that for all the things that we used to do for printing. We'll just kind of add these things into what's already there. So then what we have at the end is the thing that we were going to print to the screen is instead going to be in this string called response. And we're going to return that string. What this does is it takes whatever you pass to it, and when it returns it, it makes it part of what is in the reply. So the term assess the name Alex, that actual expression becomes way too short. So I can actually say, for example, x equals assess the name, right? I can do that. And it will put it in there. You put it into x. Because it's not printing anything. It just kind of puts it into x. So now if I check to see what x is, oops, x, it's going to be way too short because this has turned into whatever the function creates. So let's do instead of that, let's do a quick print. We'll get rid of our little X down here real quick. So we've got this. We already know what it's going to be. Let's make it that instead. And we have it printing out the response, which is it's between, we know it's less than 21. And so it's going to be bumping down to here, and it's more than 10. So it ends up with returning, that's a reasonable length. And then just for completion's sake, let's go ahead and do my full name. Okay, now I'm gonna have to do that backslash thing. We'll just leave it at Halibay. So we'll print that, right? Okay, so we have a slight problem here, and that is that because it's all in one string, it's all in one string, and that's not what we really wanted originally. The reason for that is when you do a print command to the screen, it automatically adds a new line at the end of it. But generally that new line doesn't exist in the file itself. There is a special code to kind of hit return somewhere in a file, and so we can kind of do that here. You'll remember from before that we have the backslash to kind of do a control code, and we can do \n, and that results in and that results in a new line or a return being inserted in there. We might as well do that for all of them. Kind of just say there's a new line in there. So I need to run this so that it redefines that, and then I can go down here and run this again. And now it does it on 3 separate lines because it has that new line character in there that bumps it down for each one of those. In fact, it has one at the very end there. You can kind of see that at the end here. It's got an extra line there because I put one in the end. We probably don't want that. We're probably good with it just printing as it is because the print command will add it to the very end. So this is a function. Now we can do this. We can do this, right? Let's say that we define a string, which is this name. I'm not going to put the underscore. And what are we going to do? We'll do and then on the next line we'll print assess this name for this name, right? So we kind of know what's going to happen here, right? It's going to send this name, which is Alexander Halibay, up here. It's going to evaluate that and come up with a solution. That is a reasonable length. Now, so we have this name there. Let's do something funky is happening here because we can do this name, right? And if we run that, it'll do this is a reasonable length, then it has my name. But what about up here? We have this variable my name. There's an error. The error is my name is not defined. That might look a little bit strange here, right? Because it is defined. It's defined right up here, my name. But the way this works, if you think way back to algebra, you might remember something like f of x equals x plus 1. That x only matters up here. It only matters within this definition, and within the code here, it's what's called a local variable. It's only a variable within this little program within the program, within this definition of a function. And so outside of that, outside of what's called the scope of this function, it no longer is defined. In the main program, my name doesn't even exist. It only holds, it starts its life here, it ends its life by the end of the function, and then it's gone forever. So just keep that in mind that I can call something down here this name, and that's in the main program, but up here, whatever variables I can, like the response as well. Response is inside there, right? If I ask for it to print response, This is likewise a local variable. It's not anywhere except inside here. So the things that are inside, generally speaking, the things that are inside a function, or later on we're going to talk about methods as well, things that are inside the function or the method are not easily accessible outside of the function. And so they are local to that function itself. All right. I think that gives us a good wrap up of what I hate to leave it with an error there, but of what a function looks like, and how to define your own. And the next step, we're going to try to think about some other forms of variables, especially one that's important to a lot of what we do, and to a lot of what Python does, the list and the dictionary. Thanks.